Lesson 45A is dealing with conditional permutations. The first thing we have to remember is what a permutation is. I put up a really simple example. How many ways could three boys place in a race? And you say, well, if I had three in the first place, that leaves two in the second place, and there's only one left. 3 times 2 times 1, 6 different ways. It's a very simple permutation. Conditional permutation is when we place some conditions on it. Unfortunately, this is one of those lessons where in this situation, the easiest way to show this is with an actual example rather than trying to come up with a set of rules. There aren't a set of rules that I'm going to use as far as a formula to memorize on this. I'm going to use a little more logic with it, and I'm not going to just go through and add up every one of the possibilities. I'm going to break them into logical steps and work with the problems. So 45A says, how many odd counting numbers can be formed from the digits 3, 4, and 5? Now we're going to have to use some logic here first. Okay, I need how many odd counting numbers. So odd counting numbers. So if I'm counting with odd numbers, I'm not starting at 0, and that's okay because 0 is not odd anyway. And I say 1, well that doesn't work because my numbers are 3, 4, 5. Well, 3 is an odd single digit. 5 is an odd single digit, but 4 is not. So for the one-digit counting places, how many odd numbers can I have with a single digit? Well, that's easy. That's 2. The next thing I'm going to do is I'm going to move to a 2-digit. Now I'm going to go ahead and put some conditions. The last number must be odd. Well, I only have 2 numbers that work for that, so I'm going to put a 2 in that blank. The next thing I know is any of the other 2 remaining, or either of the 2 remaining, can be used in there. But I can't use 0 because 0 would make it a one-digit counting number. So I'm not going to use that. I'm going to say that this is going to be just 2. The next thing I'm going to do is say either remaining digits in the tens place. So if I use one of the 3 numbers in the end, it doesn't matter which one I use, the next in the tens digit can be either of the other remaining, and that gives me 2 and 2. So there are 4 different 2-digit counting numbers that are using the 3, 4, and 5. And if we stopped and thought about them, we could probably figure out what those numbers were. A 2-digit counting number like 45 or 35 that end in these numbers. There's only 4 of them that do so. On a 3-digit number, and this is where it starts getting a little more exciting, I'm going to look at this and say the first 2 sets are the same, right? Because I still have only 2 odd numbers to end with. So there's that one is. But if I move over my tens digit and I say, well, how many do I have left? I still have only 2 left. This is where it's unique, and that is, what about the 3rd digit over? Well, I only have 1 more left that I can put in there, and so I do so, and I end up with 1 times 2 times 2, which is 4. At this point, I'm going to say, well, there are 2 one-digit numbers, 4 2-digit numbers, and 4 3-digit numbers. I add them up, and I end up with 10 different counting numbers that are odd that fit this criteria. Now, sometimes you have to subtract some out of this, sometimes you're adding them back in, but really what we're doing is we're breaking down what that is. Now, could I figure this out the long way? And sure, I could probably figure out 3 and 5 are the only ones for the ones, and then realizing it has to end in 5 or 3, so 35, 45, and then 43, 53, there's my 4 2-digit numbers, and then I have those same 2-digit numbers added again in the 3-digit places, but I really only have one other place this could be, so, and that's where that's what I'm doing. So I'm using the same logic that I would normally use in a problem, but I'm just applying it into the permutations and keeping up with them and then multiplying them down, adding up my totals. And this is probably the easiest way to do this. It does work every time, and will give you even really unique conditions. It can find out using this method how many different numbers exist in that range.